Hello there, welcome to Let's Do Homework Problems. Today's homework problems are review questions. So we're doing circuit problems and we're doing review. This is chapter 1 review, so it's just super basic things here. Let's just start at the beginning. 1.1. 1 millivolt is 1/1,000,000th of a volt. All right, let me move this out of the way here. Let's have a look at this. So 1.1. 1 millivolt is that 1/1,000,000th of a volt would be 1 volt. 1, 2, 3, 4, 5, 6. Those not the same. Those are not the same. This would be 0.1, 2, 3, 4, 5, 1, but 1 millivolt is 1,000th of a volt. So this is false. So that is B. Question 1.2. The prefix micro, which is that symbol, stands for is a weird way to phrase it, I feel. Stands for? Well, so we can use volt since we just did. 1 microvolt is 10 to the minus 6 volts. So if that's what they mean by stands for, then that's what that is. So we'll go with D, maybe. 1.3. The volt, I'm just confused about the stands for thing. You know, which way are they going with it? We'll go with D. That's probably what they mean. The voltage 2 million can be expressed in powers of 10 as, let's see, so 2 million would be, a million is a mega, so that would be C. 2 million, 1, 2, 3, 4, 5, 6, is 2 megavolts. Mega is my favorite one. I really love megagram and megameter, blah. Giga just doesn't really quite have the same to it. All right, 1.4. 1.4. A charge of 2 coulombs flowing past a given point each second, all right, so every second we got 2 coulombs, boom, is a current of 2 amps. Yeah, you bet. So that's true. And it's true because current, I, is equal to charge per time. Not just Q by T, you might say delta, or you might say dQ by dt, or maybe you want to use lowercase letters, doesn't really matter. And when we're talking about this change, we're talking about, this is our point, how much charge is moving past would be our change. So right now there's 0 at time 0. At some point during that second, 2 coulombs, 2 coulombs has passed by. So that would be 2 coulombs per 1 second is 2 amps. So there you go. The unit of current is, as we just saw in question 4, my microphone wire is getting trapped under my board here, 1.5, so that'll be, the unit of current is ampere. Usually people say amps though. Let's see, the voltage is measured in volts. So that one's nice and easy. Voltage is measured in volts. I think, is that the only thing that has the same name as the thing it measures? Because like distance is meters, mass is grams, current is amps, voltage is volts. Although it's probably the case that voltage as a term for what we're thinking of derives from the fact that it's the unit, right? So like you could say like footage, right? And people say that for distances. Mileage is measured in miles, that kind of thing. I wonder if you could say ampage. Maybe. Could you say grammage? Poundage? I've heard poundage. Kilogrammage? I don't know. Anyway, because voltage is actually the electric potential difference, is what it's actually measuring. All right, 1.7. A 4 amp current charging a dielectric material will accumulate a charge of 24 C after 6 seconds. True or false? Oh boy. All right, so let me, if I move it over there, I won't be able to see it either. What dastardly situation have we found ourselves in? Let's move it right there. All right, so 1.7, a 4 amp current, so I equals 4 amps, charging a dielectric material, okay, whatever, will accumulate a charge of 24 C, so Q equals 24 C, after 6 seconds, so T equals 6 seconds. So this is what we're talking about, right? We just did it up here, so this is the same sort of situation. Is this true? So we'll just pop it into there, and we have 4 equals the charge that has happened, 24, divided by the time, and that is true. So we're going to go with A. All right, switch this over to that side. 1.8. The voltage across a 1.1 kilowatts that produces, it's a toaster. Great, so it's a toaster. So we've got a toaster, and it's popping up some toast here. Maybe it's like a little burnt. So it's got some toast popping out. So that's, it pops out. Okay. That produces a current of 10 amps. All right, so we got some power, and we got some current, 10 amps. So toasters don't produce current. They can use it up, but they're not typically known to produce it. So we'll just ignore that. What is the voltage? All right, so well, power equals current times voltage. So that would be 1100 watts. Make sure you do that conversion correctly. 1, 2, 3 equals the 10 amps times volts. So volts equals 1100 divided by 10. Cancel out the zeros, 110 volts. So that is C. C. All right, 1.9. Hopefully I can get all these on here without having to erase. I'm gonna have to pause the video if I have to erase. This is flat, and so the dust gets everywhere. Which of these is not an electrical quantity? So we got charge. We've been using charge. Time. Well, we've been using time. Voltage. We've been using that. Current. We've been using that. We just used power. So I don't know. Well, it's time. So it's time. Charge, voltage, current, and power. Well, charge, voltage, and current are exclusively for electrical stuff. Power is for other things. I guess technically, like, oceans have current. You know what I mean? It's got to be time, right? Yeah, it's got to be time. Current has charge per time, so there's charge in there. Voltage also has charge in there, mixed in. Power clearly has both of those in there. Time's the only one that's, stopwatches do time, right? So hourglasses use time, stopwatches use electricity. So anyway, the dependent source in the figure is blah. Okay, so there's a couple sources here. We've got, if I was extra fancy, I'd be able to point at the picture, but I don't have whatever it is you need to do that. So we will just doodle it again here. And I'll turn off my face. Don't worry. Turn my face off here. So we've got a plus, minus, got an I0 here. Guess we're doing lowercase. I don't care. Uppercase for me, thank you. 6 I0. All right. So this is an independent source. That's how they like to write those here. Anything that's the little diamond shape or the little square that's been rotated shape, that's the dependent source. And so there's different kinds of those. We've got the current ones, the ones that provide current, have an arrow. the ones that provide voltage have a plus minus. So that's those. So current and voltage. If it's current controlled, it has a little indicator of its dependency there. And I0 is a current. We can tell because of this arrow here telling us where I0 is. It's the current in this wire. If it were voltage controlled, it would have like 3. The number isn't important. And it would say like V1. And V1 would be, say, like the voltage. You do like plus minus, and you'd say it's the voltage across that element. And then that would be voltage controlled. So in that case, it must be a current source. So it is either A or D, because it has the arrow there. And because it is controlled by a current, it must be current controlled current source, which is D. Easy peasy. All right, so that's those. Hope you enjoyed. Hopefully you managed to get those before I ended up getting them. See you next time.